Welcome to this explainer. Today, we're unpacking the mechanics of network lateral movement. Now, I want you to think of this topic kind of like a highly sophisticated digital heist, right? Once operators bypass the perimeter and actually get inside a network, well, they don't just magically have access to everything. They have to navigate a maze. They're moving from room to room, overcoming a whole series of really complex technical obstacles, and they got to do it without tripping the alarms. Our source material today breaks down exactly how this is done in adversarial emulation, and we're going to walk through it step by step.
Okay, so here's our roadmap. We'll start off by demystifying lateral movement, and then we'll compare our core tools, jump versus Remote-Exec. Next up, we'll look at the OPSEC footprint, the loud and the quiet. Then we'll expand our arsenal with custom hacks and LOBAS, and finally, we'll untangle a really notorious post-movement trap.
All right, Section 1, Demystifying Lateral Movement. Before we get into the tools, let's just quickly set the stage for what this actually means when we're talking about adversary emulation.
When we anchor this in frameworks like MITRE ATT&CK, where, by the way, this is classified as Tactic TA0008, the definition is actually surprisingly straightforward. It's just gaining access to other computers on the network. But the crucial part here is how it's done. Look, operators aren't usually burning, million-dollar zero days just to move from room to room. No way. Instead, they typically rely on legitimate remote management protocols using administrative credentials they've already swiped. It's absolutely all about blending in. And usually, you achieve this by uploading a payload to a target and then executing it remotely.
That brings us perfectly to Section 2, Jump versus Remote-Exec, the core toolkit. Let's look at the two foundational primitives that a framework like Cobalt Strike provides for actually executing these commands on a target. These are essentially our digital lockpicks.
So let's talk about the jump command. Think of this as your easy button for lateral movement. It's basically an automated concierge service that handles 4 distinct steps in perfect sequence for you. First, uploading the payload to the target machine. Second, executing it remotely. Third, connecting to your shiny new session via peer-to-peer communication. And finally, step 4, covering your tracks by deleting the payload. Seriously, just running the command by itself will even show you the available techniques you can use. It handles the entire lifecycle for you, so you literally don't have to break a sweat.
Now, the really crucial point here is understanding exactly when to use Jump versus our other tool, Remote-Exec. Like we just said, Jump is your automated all-in-one capability. But what happens when the built-in jump techniques fail? Or, what if an overzealous antivirus gets suspicious and just jams the lock? Well, that's exactly where Remote-Exec comes in. It's a much broader capability for executing remote commands, but it requires you, the operator, to manually carry out those individual steps we just talked about. You got to do the uploading, the executing, the connecting, and the cleanup yourself. It's absolutely necessary for those edge cases where technique just cannot be reliably integrated into the automated jump command. Basically, it hands the manual control back to you when you really need it.
Okay, now that we've got our basic tools down, let's move right into Section 3, the loud and the quiet, PsExec, and WinRM. We're going to examine the OPSEC, the operational security footprint of these actions.
Understanding your footprint here is fundamental. Let's compare the loudest technique to one of the quietest. I want you to think of PsExec kind of like kicking down the front door. It's actually the only built-in technique that performs remote injection by default, but it does it by dropping a payload to disk and creating a brand new service to run it. And because new service creations are relatively rare on a day-to-day basis, well, this sets off alarm bells. It's incredibly loud, even though, yeah, it does grant you system-level privileges instantly. Now, on the flip side of that, we have Windows Remote Management, or WinRM. WinRM is like using a master key. It executes your payload entirely within memory. Literally nothing drops to disk. Plus, it runs in the context of the current or impersonated user, which makes it incredibly quiet. And as a huge bonus, WinRM is the only Remote-X method that actually returns output, meaning you can use it for remote enumeration without flying completely blind.
Moving right along, let's hit Section 4, Custom Hacks and LOBAS, expanding the arsenal. Because let's face it, when default techniques like PsEx get detected, operators have to adapt.
So, when those default tools trigger alerts, what do? Well, you get creative. Charles Hamilton's SC shell project, which is something you can actually load directly into Cobalt Strike as an aggressor script, brilliantly solves the PsExec noise problem we just talked about. Instead of creating a brand new, highly suspicious service, SC shell temporarily modifies an existing service to run a payload, and then it just restores it back to normal right afterward. It's literally the digital equivalent of borrowing a security guard's badge for like 5 minutes and returning it to their desk before they even notice it's gone. You completely avoid the massive red flag of a new service creation.
Another really cool strategy to expand our arsenal is through living off-the-land binaries, or LOBAS. The total irony here is that you're taking Microsoft's own signed native files and using them against them, kind of like an inside man. Take mav-inject, for example. It's a completely legitimate executable sitting right there in the System32 directory, originally designed for app-v functionality. But because it's signed and fully trusted by Windows, threat actors can actually abuse it to inject any arbitrary DLL into a chosen target process. You'd simply use your Remote-Exec to list running processes, upload your payload, and then let the native mav-inject tool do the dirty work of injecting it for you.
But hey, let's take a quick reality check here. The source material provides this vital bit of context. Most mature organizations have a good handle on LOBAS abuses. They can be blocked outright using application control technologies. Technologies like AppLocker, Windows Defender Application Control, or even process monitoring via Sysmon can absolutely spot or stop these abuses dead in their tracks. So what you should really take away from this is that while LOBAS are definitely fascinating, their use is generally far more applicable to adversary emulation, where you're actively testing a mature defense rather than just basic simulation, where honestly, you might just get blocked immediately.
All right, we're now entering the final stage of our digital heist. Section 5, the security logon trap, the post-movement gotcha. So picture this scenario. You've successfully moved laterally using WinRM. You're feeling pretty good about yourself. You're sitting on the new target, and you immediately run a domain enumeration tool, something like get-domain trust, just to map out your next move. And bam, it throws a massive exception. It fails completely. You've hit a brick wall. Why in the world does this happen? Is the tool broken? Is it some weird bug in the framework?
Actually, scratch that, it's not a bug at all. It is a strict consequence of Windows logon types. See, when you authenticate to a Windows machine, the operating system very carefully categorizes exactly how you logged in. Out of all the available types, interactive, batch, service, all of those, the real culprit here is the network logon type. Both WinRM and PsExec, which, remember, are the two primary tools we focused on today, they authenticate using this exact type. And man, this carries a very, very frustrating restriction for operators.
Let's dig into the technical why behind this trap. The network logon type is uniquely paranoid. It is the absolute only logon type that does not leave your credentials in LSSS on the remote target. I mean, no NTLM hash, no Kerberos ticket granting ticket, no plain text password, nothing. If you look at the tickets in your new session, literally all you have is the HTTP service ticket that allowed WinRM to connect in the first place. And here's the kicker. Without a TGT and LSSS, you simply cannot request a service ticket for LDAP to query the domain. You are entirely cut off from domain enumeration. You're effectively locked in a room. To break out of this, you're forced to leverage user impersonation techniques, things like make_token or pass the ticket, just to populate that session with credential material so you can finally authenticate to domain resources.
But before you go running down the rabbit hole of token impersonation and injecting new tickets, our source material leaves us with this brilliantly provocative question. Must that domain enumeration actually be done from this new session? Or could it just be done from the session you jumped from in the first place? You know, the one that already had the credentials? It's a really powerful reminder that in lateral movement, sometimes the biggest obstacle isn't the technical restriction of the operating system at all. Sometimes it's our own tunnel vision. Think strategically. Don't just blindly move forward. Thank you so much for joining me on this explainer, and I really hope this completely reshapes how you look at navigating a network.